We're going to work on solving system of nonlinear equations. In this case, we will have a system of equations that involves a circle and a line, or a circle and a hyperbola, or a hyperbola and an ellipse, or two parabolas, or different kind of conic sections together combined with linear equations. Let's look at the examples. We're going to talk about solving these using the substitution method or elimination method, but we can also look at these graphically and see what does that solution means. Sometimes we'll have one solution or 2 points where the curves intersect, or we can have more than 2 points where the graphs intersect as well. So y equals x squared, 3x plus y equals 10. This one looks like it can be easily solved using substitution. So I'm going to go ahead and substitute y equals x squared into the second equation. So 3x plus x squared equals 10. And now let's go ahead and solve it. This leaves me with x squared plus 3x minus 10 equal to 0, putting it in a nice clean shape and form. X plus 5, x minus 2 equals 0 when we factor it. So we get x equals negative 5 and positive 2. So now in this case, when x is negative 5, what is y going to be? When x is negative 5, y is going to be x squared, which is negative 5 squared is 25. When x is 2, y is going to be x squared, which is 2 squared is 4. So I'm going to have two solutions, 2 points where these curves intersect. The first curve is a parabola, and the second curve is a line. So let's see, the points of intersection are negative 5, 25, and 2, 4. X goes first, y goes later. If I were to think about this graphically, I have a parabola, y equals x squared, and a line. So this is a very rough sketch. This is where 2, 4 is, and this is where negative 5, 25 is. Again, this is a very rough sketch, not drawn to the scale. Okay, number 2, we have a circle. X squared plus y squared equals 25 is a circle, and 3x plus 4y equals 0 is a line. Let's see the circle and line. And when we're solving these systems, sometimes we'll get no solution because we can have a circle and line far away from each other, not touching each other at all. So I'm going to solve this using the substitution as well. We can isolate x from the second equation. So 3x equals negative 4y, x equals negative 4/3 y, and replace the x in the first equation with this value of the x. So negative 4/3 y squared plus y squared equals 25. Leaves me with 16 over 9 squared plus y squared equals 25. Let's go ahead and clean it up. We can multiply the entire equation with the 9. 16y squared plus 9y squared equals 25 times 9, and that's 225. 16 plus 9 is 25, y squared equals 225. Y squared is 225 over 25, which is 9. Y comes out to be plus and minus 3. When we take square root, there's two values of y here that will make this equation true. Y squared equals 9. There are y equals positive 3 and negative 3. Now let's go ahead and figure out what is x when y is positive 3 and what is x when y is negative 3. So when y is positive 3, when y is negative 3. When y is positive 3, it's a lot easier to plug it into this form to figure out when y is positive 3, the x is going to be negative 4. And when y is negative 3, x is going to be positive 4. So my two solutions are negative 4, 3 and 4, negative 3. And we did have a line here. We had a line and a circle. So line and a circle means my circle was x squared plus y squared equals 25. So it's going to have a circle with the radius 5. It's going to look something like this. And we had the line passing through it. So it is touching at the point when x is negative 4, y is 3, and when x is 4, y is negative 3. So something, again, not drawn to the scale, and this is how my graph going to look like. This line is not passing through It's going to be 4y equals, if I do 4y equals negative 3, y equals negative 3/4 x. So it is going to pass through the origin, and that's how the graph is going to look like. See another example, we have a line, and the next one to me, because only x is squared, that looks like a parabola. So this one is a line and a parabola. Now, line and a parabola, again, can intersect at 2 points, or 1 point, or none. So let's see what happens in this case. Again, I'm going to go ahead and use substitution. I can say from the first equation, y equals 4 plus x. And I'm going to plug this into the second equation, y equals 4 plus x. So x squared plus 8x. It's probably easier to call this equation A and equation B. That way we don't confuse with, we don't mix them up, and we always plug it into the other equation, not the back into the same equation from wherever we isolated the y. So x squared plus 8x equals, instead of y, we're going to write 4 plus x minus 16. Now let's go ahead and solve it. Simplify it. X squared, bring the x's to the left hand side when we subtract the x. 4 minus 16 is negative 12, but when we bring it to the left hand side, it becomes positive 12. So factors in this case, x plus 4, x plus 3 equal to 0. So we get two values of x, negative 4 and negative 3. Negative 4 and negative 3. So we need to figure out when x is negative 3, what is y equal to? When x is negative 3, we can use this relationship, y is equal to 4 plus x. Y is going to be 4 minus 3, which is 1. So negative 3 comma 1 is one solution I have. When x is negative 4, y is equal to 4 plus x. 4 plus negative 4 is going to equal to 0. So negative 4 comma 0 is another solution I have. And in this case, we said that we had a parabola as well as negative 4 comma negative 3 and negative 4 comma 0 are my two solutions here. We had a parabola and a line, and I'm not going to go ahead and graph it, but I'm not going to spend too much time graphing, but I think it is going to look something like this, a parabola and a line, and they're meeting at, the line is y minus x equals 4, or y equals x plus 4. The line is y is equal to x plus 4. Okay, they are meeting at negative 4, negative 3, and negative 4, 0. X is negative 4, y is 0. X is negative 4, y is negative 3. So I'm thinking it is going to look something like this. Again, very rough draft. I'm not spending any time on graphing, just to kind of show you how graphically solving this system would be. We would rewrite this in the standard form, find the vertex and all that to get a more accurate graph. Or you can also use Desmos to graph both the equations to verify that your solution is correct. Okay, next we have number 4. In this case, the first graph is a line. The second one is a rational function, y equals 1 over x. We can start by isolating the y from the second one, or from the first one, it doesn't really matter. So let's call this equation A and B. So from equation A, we can say y is equal to 6x minus 5, isolating the y. And now we're going to replace this y in the second equation. So x times 6x minus 5 is equal to 1. Let's simplify. 6x squared minus 5x minus 1 equal to 0, putting it in the nice shape and form. And to factor this quadratic, I'm going to use bottoms up method. So two numbers multiplying to give me negative 6, adding to give me negative 5 or negative 6 and 1. Divide them both with the 6x and 6x. So factors are going to be 6x plus 1 and x minus 1. So x equals negative 1 and negative 1, 6 are the two values of x that we got here. we have the x values. We also want to find out when x is -1, what is y equal to? When x is -1/6, what's y equal to? Oh, x is going to be +1, not -1, because when we use the zero product property, we'll plug this factor equal to 0. We're going to be adding 1 on both sides to isolate the x. Okay, so when x is 1, let's go ahead and plug it into y is equal to 6x minus 5. So 6 minus 5 is also equal to 1. So it looks like 1, 1 is my 1 coordinate pair. When x is -1/6, y is equal to 6 times -1/6 minus 5. And that's going to leave me with cancel these out. -1 minus 5 is -6. So -1/6 and -6 is another piece that I have where the graphs are intersecting. Okay, and just a really rough sketch of how the graphs look like. We know y is equal to y is equal to 1 over x looks like this. And the first line, which is y is equal to 6x minus 5. So they're meeting at 1, 1, which is here, and at -1/6 and -6. When x is -1/6, then y is -6, about here. And this line, this is how the line is going to look like. So a rational function and a line. Another example, again, looks like we have a circle and a line, and we know circle and line can meet at 2 points, 1 point, or 0 points. So I'm going to go ahead and call this equation A and B. From equation B, I'm going to isolate one of the variables, which we can either isolate y or x. I'm going to go ahead and isolate y. Now plug y is equal to -x plus 5 into the first equation. So x squared plus -x plus 5 squared equals 9. That gives me x squared plus 10x minus 10x actually. Minus 10x plus 25 equals 9. So 2x squared minus 10x plus 16 equal to 0. We can go ahead and divide everything on both sides of the equation with the 2. And this equation is not factorable. So what we'll do is, because it's not factorable, we're going to go ahead and try to use quadratic formula to solve for the x value, because we could have a decimal value here. An irrational number could be the x value that we could have here. So let's see. X equals -b plus minus square root of b squared minus 4 times a times c divided by 2 times a. So the 5 plus minus square root of 25 minus 4 times 8 is 32 over 2. So this looks like there is a negative inside the square root, which is going to leave me with an imaginary solution. So there is no real solution for this system of equations. And if you want to verify, we can go ahead and see that too. We can draw our circle with the radius 3. That would be about here. And then it should be all okay now. All right, that looks better. Okay, circle with the radius 3, and then x plus y equals 5. That should be y is equal to -x plus 5. So that's going to be a line starting at y equals 5 and then going down. So that's how the line is going to look like. My line and circle are not going to touch in this case. Another example, we have x squared plus 2y squared equals 12. That looks like an ellipse. This looks like an ellipse to me. And the next 7y squared minus 5x squared, because I have negative in the middle and the coefficients are different, this one looks like a hyperbola, and vertical hyperbola because we have y squared term first. To solve this system, I'm going to go ahead and use the method of elimination. So I'm going to Do x squared plus 2y squared equals 12. 7, okay, let me rewrite it. Negative 5x squared plus 7y squared equals 8. I'm going to multiply the first equation on both sides with the 5. So that's 5x squared plus 10y squared equals 60. Negative 5x squared plus 7y squared equals 8. The reason why I did that, I wanted the numbers in front of x squared same but opposite because I wanted to use elimination method here. Substitution would work out as well, but it's going to be much more tedious and I might have square roots and fractions. So elimination is a lot easier in this case. Now I'm going to go ahead and add the two equations. 17y squared equals 68. Y squared equals 68 divided by 17, which is 4. So y squared is 4, gives me y equals plus minus 2. When y is equal to 2, what is x going to be? Let's plug the y equals 2 in here. So x squared plus 2 times 2 squared equals 12. X squared plus 2 squared is 4 times 2 is 8 equals 12. X squared equals 12 squared, 12 minus 8, which is 4. X equals plus minus 2. So it turns out when x is 2, y is 2. When x is negative 2, y is still 2. So we got 2 points already, but we also have to deal with when y is negative 2. So let's go ahead and replace the y by negative 2 in the same equation. And it's going to leave us with x squared plus 8 equals 12, x squared equals 4, x equals plus minus 2. So in this case, there's going to be 4 solutions. When x is 2, y is negative 2. When x is negative 2, y is negative 2. Okay, and we said that this is an ellipse and a vertical hyperbola, so most likely it is going to be something like this. Again, not drawn to the scale, a very rough sketch. I'm going to be using here an ellipse and a hyperbola. That would look, because we are intersecting at 4 points, so these will be the 4 points of intersection here. Right, let's see, next example, number 7. We do have 3x squared plus 2y equals 26. This looks like a parabola to me because only x is squared. And the second one also looks like a parabola. To solve this system, let's go ahead and try to do elimination as well. We can do substitution, but elimination looks like easier here. So I'm going to call this equation A and call this equation B. So I'm going to do negative 5 times the first equation plus 3 times the second equation. So I'm going to multiply the first equation with negative 5 and second equation with 3 to get the coefficients of x squared same but opposite. And then I'm going to add the two equations. So that leaves me with negative 15x squared minus 10y equals 26 times 5 is negative 130. And then 15x squared plus 21y equals 3 times 3 is 9. Now when we add the two equations, 21y minus 10y is 11y equals negative 121, y equals negative 11. When we see y is 11, we want to find out the x. We can replace this y into the either equation. So when y is 11, what is x? I'm sorry, negative 11, what is x going to be? I'm going to use the first equation, 3x squared plus 2 times negative 11 equals 26. 3x squared minus 22 equals 26. 26 plus 22, and that's going to be 48. X squared equals 16 because 48 divided by 3 is 16. X equals plus minus 4. So there's our solution. When x is 4, y is negative 11. When x is negative 4, y is negative 11. And in this case, we did have two parabolas. Again, a very rough sketch of the two parabolas. I think both parabolas are going to be opening. If we get the y by itself, both parabolas are going to have the first term negative. So they're going to be opening down. So it looks like they would be something like this. Again, very rough sketch without much work in graphing. So 4, -11, and -4, -11 are the points where the graphs intersect. Next example, this one looks like we have an ellipse and a line. 6x squared plus 3y squared equals 12 and x plus y equals 2. Again, go ahead and give it a try. Pause the video. You can use the elimination method here. Actually, we cannot use elimination method because if I go ahead and square both sides, I will have an ugly term with x, y included in it. So no elimination method. Elimination method will not work here. So we have to use the substitution method only, which means we can isolate the x or y from either equation. So this is my equation A and B. From the second equation, from B equation, I can see y will be negative x plus 2. So plug y equals negative plus x plus 2 in A. 6x squared plus 3y squared equals 12. We're going to replace y by negative x plus 2 in here. And let's go ahead and solve. We have to first FOIL or distribute or open up the binomial here. Only then we can distribute the 3. So it turns out to be x squared minus 2 times 2 is 4x plus 4 equals 12. Let's distribute a 3 inside. 6x squared plus 3x squared minus 12x plus 12 equals 12. Combine the like terms. 9x squared minus 12x. 12 minus 12 will be 0. We can go ahead and pull out a 3x. 3x minus 4 equal to 0. So when we use the zero product property, we get two x values, x equals 0 and x equals 4. When x is 0, we can plug into the yellow highlighted value to find the y value. When x is 0, y turns out to be 2. When x is 4/3, y turns out to be negative 4/3 plus 2, which is going to be 2/3. So my coordinate pairs, the points or the solutions, points where the graphs intersect, are 4/3, 2/3, and 0, 2. And in this case, we did have an ellipse and a line, right? Yep, ellipse and a line. And ellipse is going to look, because the x term is bigger, so it's going to be something like this. And the line, and they're meeting at a point when x is 0, y is 2, which would be about here. And when x is 4/3, y is 2/3, that'd be about here. So that's just a very rough estimate. This is how the graph is going to look like. Next example, this is going to be our last one. We have x squared plus y squared equals 9. That is a circle. X squared minus y squared equals to 1. That is a hyperbola. And to solve this system, I think the easiest method is right away we can add the two equations. Go ahead and add the two equations. Add equation A and B. So we want to add a plus b. That's 2x squared. Y squared and negative y squared cancels. X squared equals 5. X equals plus minus square root of 5. When x is positive root 5, what is y going to equal? We can use either equation. I'm going to go ahead and use the first one. X squared plus y squared equals 9. Actually, maybe it's easier to use the second equation with the 1 on the other side. So I'm going to replace x by square root of 5 minus y squared equals 1. Square root of 5 squared is 5 minus y squared equals 1. That's going to give me, if I add y squared to both sides and subtract 1, 4 equals y squared, y equals plus minus 2. So square root of 5 comma positive 2, square root of 5 comma negative 2 are my two solutions. But then don't forget, when x is negative square root of 5, I'm going to have two more solutions. X squared minus y squared equals 1. Negative root 5 squared minus y squared is 1. Again, I get y squared equals 4 here, because when we square the negative inside the parentheses, that's not going to have an effect. that would just leave us with the same 5 minus y squared equals 1. So y equals plus minus 2. So again, when x is negative root 5, y is 2. When x is negative root 5, y is negative 2. There's our 4 solutions in this case. And that's it for solving the system of nonlinear equations.